Let's look at orthogonal projections. Given two vectors y and u, we have seen how to write y as a multiple of u plus some vector z orthogonal to u. So here's y. Y equals y hat. This is a vector that's parallel to u. And z is a vector that's orthogonal to u. So y equals y hat plus z. Y hat is what we sometimes call the projection of y onto u. Now let's look at a generalization. More generally, suppose we have a subspace W of Rn. Any vector y in Rn can be expressed as y equals y hat plus z, where y hat is in W. It's in the subspace W, and z is in W perp. What is W perp? It's the set of all vectors in Rn that are orthogonal to every vector in W. We can use a formula we learned earlier. If v1, v2, blah, 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 v sub k is an orthogonal basis of W, then y hat is going to be y dot v1 over length of v1 squared times v1 plus y dot v2 all over length of v2 squared times v2, blah, 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 blah. We call y hat the orthogonal projection of y onto W and write this. So y hat equals the projection of y onto W. As before, z is going to be y minus y hat. In other words, it's going to be y minus the projection of y onto W. For example, let y equal 1, 2, 3, v1 equal negative 7, 1, 4, v2 equal negative 1, 2. Negative 1, 1, 2. Write y as the sum of vector w in span v1, v2 and a vector in w perp. Note that the set v1, v2 is an orthogonal basis for the span of v1, v2 because these two vectors are perpendicular to each other. So y is going to be y1 or y dot v1 over length of v1 squared v1 plus y dot v2 over length of v2 squared times v2. In other words, so here's y dot v1 over length of v1 squared times v1. And here's y dot v2 over length of v2 squared times v2. When you do the math, plug in all the numbers, you end up with 3 33rds, negative 24 33rds, 69 33rds. So z equals y minus y hat. It's going to be y, which is 1, 2, 3, minus the vector we just found a moment ago. And this works out to be 30 over 33, 90 over 33, 30 over 33. And z is orthogonal to both v1 equals negative 7, 1, 4, and v2, negative 1, 1, negative 2. So z is orthogonal to the span of v1, v2, set of all linear combinations of those two. And you can check. It turns out that y equals y hat plus z is going to be 3 33rds, negative 24 33rds, 69 33rds, plus 30 33rds, 90 33rds, 30 33rds. Y hat is in W, the span of v1, v2, and z is in W perp.